All right, so in this video, I'm going to talk about significant figures, something we've worked on a few times in class. So significant figures are basically just a way of saying what numbers are important, what numbers are the ones that you were actually able to measure. And so the definition that was given in the book is it's all the numbers that are definitely known plus one that is estimated. So I want to give you an example of a ruler here. If I'm measuring something with a ruler and I know that it's right here, I definitely know it's at least a 6. And then I'm estimating which of these other markings that I'm at. It's a little tricky with inches because we use fractions instead of decimals. But when you look at it like a centimeter, like if I'm looking right here, I'm definitely at 10. I can estimate at zero point 0.5. So if I look at a number like 10.5, what I'm saying is these are known plus 1 of estimated. And that makes 3 significant figures. This is also the same as saying it's at 1 decimal point. So just be aware, sometimes they'll use DP, sometimes they use significant figures. There's a couple tricky things about significant figures, and that has to do with the number 0. Anytime a number is not 0, it definitely counts for a significant figure. But there's kind of 3 different situations where zeros can happen. Here's one situation. If you have got a whole number with zeros at the end, these are significant figures, these are not. And so this number has 3 significant figures. So zeros at the end of a whole number don't count. Zeros at end of whole numbers are not significant figures. And the idea there is you've got a big ruler that can only measure to the nearest 1,000. Can't measure that precisely. However, if I had a number like this, 105.000, these are significant figures. These are also significant figures. And the idea there is if I just meant 105, I would have just written 105. But putting a 0.000 means I've got a super precise ruler. So if you write zeros after the decimal, you're communicating you had a super precise measuring tool. So this number here has 3 significant figures. So zeros at the end of decimals are significant figures. There's one other tricky thing. If I have a number like this, 0.000105, these are not, but these are significant figures. So that's 3 significant figures. Oops, I just realized I made a mistake. This isn't 3, this is 6. I told you to count them, and then I messed up and counted them wrong. There's 6 of them. There's the 105 and there's the 0.000. Sorry if that confused you. So the zeros at the end of the decimals are significant figures. This next one, the zeros here don't count because they're before the non-zero digits. So zeros to the left of digits of decimals don't are all right, not significant figures. Okay, so to summarize significant figures, they're telling you how precisely you can measure. So it's a way of communicating how precisely you measured something. Did you use a really imprecise measure, or did you use one that's really precise? If you have zeros at the end of whole numbers, those don't count. If you have zeros before decimals on the left side of decimals, those don't count. The only time that zeros count is if they're in between non-zero numbers, like 105, or if they're after the decimal, like in the second example that I briefly screwed up on. Those count because if you didn't have that level of precision, you would just write 105. When you write 105.000, you're telling me that it's more precise. So that's significant figures. Please comment or ask questions if anything was confusing. And sorry about the little mix up with counting the significant figures there.